Welcome back to the Max Runout YouTube channel. My name is Paul, and we're back with our part 5 of our series on making gears in the home shop. This will be the last video on that in that series. And if you remember, in the end of part 4, we got some successful gears made with the automatic process. But I wasn't real happy with the shape of the teeth. They were a little too stubby, and I didn't think they were cut deep enough, or perhaps not the wrong shape. And so I decided in this segment we're going to take a look at measuring the gears and looking for what the problems might be. One of the problems I mentioned was the numbering of the gear cutters. I thought maybe I was using the wrong gear cutter, but I did a little research on that subject, and I found out that the metric gear cutters are numbered the opposite of imperial or domestic U.S. gear cutter numbers, and so the one group starts with the smallest gears on one end of they're all numbered 1 through 8, but one of the I think it's the domestic gears start with the smallest gears being number 1 and the rack being number 8, and the metric gears is the reverse of that. So I got convinced after looking at a number of sites on the web that that's what the problem was, and so I was in this long story short, I was using the correct cutter, and so that wasn't it. So the next thing I wanted to do was to find some way of measuring the depth of the teeth and to see if I was doing that part right. So we're going to start that as the first step in this video. This is a mechanism I came up with for testing the depth of the gear teeth. As I said, I was suspected that perhaps I wasn't cutting the teeth deep enough, and so I started with this mechanism here, which is that little gear tester I showed you at the end of the last video. I just took this slider here and I turned it 180 degrees to bring the gear out to this side. Originally, I kind of confirmed that the teeth weren't being cut deep enough by when I had the thing in the other configuration. I meshed the two gears and I slid them. I tried to slide them together to the correct center to center distance, but what I found was that I could not reach that distance. The gears would not get close enough together, or mesh close enough to get the right center to center distance. So now, I suspected that the teeth weren't deep enough, or maybe in the wrong shape, but certainly not deep enough to meet that requirement. And so I decided to build this slash up, which is a way of measuring the depth of the gear teeth. I didn't have a good way of doing that because it's hard to reach into these. Whoops, here we go. There, reach in the little slots of the gears and make that measurement. I didn't have anything fine enough to do that. So I started by making a piece on the mill here. This is, we're going to find it. Yeah. This is the device that I made. It's just a round piece of stainless, 5/16 of an inch in diameter. And the two ends, or the end, I fed into the mill from both directions to make that little point, or knife, kind of almost like a knife blade, but with a dull end. I'll get it in a mode where you can see it better here in a minute. But anyway, so this is just a block of aluminum that I drilled a 5/16 hole in. I actually drilled and reamed a 5/16 hole, so I had a real nice fit for this tester blade, I guess you want to call it. And then back here is a dial indicator. So if I put this in the slot and run the dial indicator back, and I'm going to tighten the bracket here a little bit. So it holds still. I can now measure the depth of penetration of the into the gear tooth, and if I set this on 0, and let's zoom in here so you can see what's going on with the you can see this is that little blade I was telling you about that I made, and that fits right into the root of the gear tooth, and the dial indicator reads a given number, and if I set that at 0, which it is, you can see it's, well, it's hard to see the dial from here, but it is reading 0. You're gonna have to take my word for that. But and then if I now take it, so that's the root of the tooth. And now if I just take this and turn it 90 degrees, now it sets on the top of the teeth, or the outer diameter. And so if I take the difference between those, it is the depth of the tooth. And if we go and take a look now, let's see if I can do this. I'll back up a little bit. Look at the dial indicator. These are always hard to see with glare, but you can see it's reading about 62 there. And if I drop it in the slot, there, it's reading pretty close to 0, maybe a little bit off, maybe a thousandth off. And then when I turn it 90 degrees again so that it's riding on there, I'm getting about 65 now. I got 62 the last time I measured. Let me try it again here. At 0, I'm getting about 62 and a half now. So all the references that I found for the depth of the teeth show the hole depth, so-called hole depth, to be about 68 thousandths. And there was one, well, a couple references where I use a little different method. I compared the ID and the OD and divided by 2, and that came out 71 thousandths. So the right answer is somewhere between 68 and 71, and I am at 62 now. And so I think that's my problem. And so we're going to make some changes to the gears. I'm going to first try maybe modifying the gears that I have, although that's going to be a little tricky to get that accurately set. Or alternatively, I'll make a new set of gears, and we'll try it again. I want to make sure I get this right before I make a lot of gears, so that's the next step. I guess I should do a little explaining regarding this device here. This bottom piece is what I call a mini pallet. It's actually a copy of something that I picked up from Tom Lipton's website. Its primary use is on the milling machine. I fit this in the milling vise, comes in and holds it in this way, and it's used to hold small parts to be machined in the vertical mill. So I can come down here and I can clamp parts down with these different clamps that I have, and they're just simple. They have a the clamp has one screw that goes down that holds it away from the base. This is a threaded hole in the clamp here, and the other screw, I guess the better way to show that is this way. The one screw, this one here, let's look at, holds against the face of the pallet, and the other one bears down on it with a nut here. So this one's threaded, and this hole is just a slot here. and it's used to hold down, you know, various things to to work on the milling machine. And in addition, it's kind of a sacrificial device in that you can clamp things down that you have to mill all the way through, and there's probably a few examples in here of that. But what happens is you mill into your piece a little bit, but once you get too many of those in and you don't have a flat surface anymore, you can just come through with a fly cutter and cut it off again. So that's what this is, and I'm just happen to be using that for this lash up that I've got here. The other piece is my little gear tester that I told you about in at the end of the last video, and this is actually a slider, and so I can bring these gears as close together as I want, and then once I got them where I want them, I can clamp them down by tightening the two screws here. In the last clip, I had the gear turned around so it was on this end, and I was using this probe to measure the depth of the teeth. Now I've reversed this slider, so now the two gears fit together, and I'm able to measure the center-to-center distance. And so doing that, I came up with a measurement here of about 1.475 approximately, which is the distance between these two shafts. Now each shaft is a half an inch in diameter, so you have to subtract a half an inch from that. There's a quarter inch on this side and a quarter inch on this side, so if you subtract a half an inch from that, you come up with the actual center-to-center distance. Okay, now we're going to get into a little bit of math here. I'm working with a book, a text called Elements of Metric Gear Technology. I found that on the web. There's PDFs of this text on a couple of different websites. Apparently it was originally developed by the Stock Drive Products folks with help from some consulting engineers, but it seems to be the Bible on metric gears. Some of the domestic references have just a couple pages on gears, but this is a, I don't know, 50 or I don't know, 80 or 90 page document on concerning gears, and then there's more addendums to it as well. So anyway, it seems to be kind of the Bible on metric gears. So just from the very definitions there, we can come up with the whole depth. And the whole depth is the distance from the top of one tooth to the bottom of the valley next to it. And that is, from the very definition, is 2.25 times the module. In our case, the module is 0.8, so 2.25 times 0.8, that means the depth of the tooth should be 1.8 millimeters, and if you can convert that to inches, it's 0.071, 71 thousandths. But now when I measured the gears, as I did in the last clip, the 30-tooth gear, I went on and measured that a bunch of times in a bunch of different locations on the gear, and they all came out in the range of 61 to 62 thousandths, whereas the desired depth was 71 thousandths. And in the 31-tooth gear, they all came out about 62 thousandths. So I'm definitely, if I assume 0.62, I'm definitely about 9 thousandths shallow on both gears. And so that would be 18 thousandths for the two together. Now, I went and measured the center distance, and as I said, that came out Oh, well, this is the calculated center-to-center distances, and this is again from the book. The number of teeth on the first gear plus the number of teeth on the second gear times m, which is the module, all divided by 2. So if I take 31 for the first gear, 30 for the second gear, multiply that by 0.8 for the module divided by 2, comes up to 24.4 millimeters and 0.961 inches. So that should be the center-to-center distance. And so then now let's take the measured center-to-center distance, which I just did a few seconds ago. That is 1.475 is the number I got, minus 0.5 is 0.975. And so we're tight on that. In fact, I take 0.975, which is the measured distance, the minus 0.961, which is the calculated distance, and we're 0.014. We're wide by 0.014. In other words, it should be 14 thousandths closer. And of course, in this case, I've put the gears as close together as they'll go, not in their running position. So I'm showing that we're 18 thousandths, the teeth are 18 thousandths shallow, 9 on each gear, and the center-to-center distance is 0.014 wide, which is starting to make some sense now, because if the gears had the right depth teeth and you put them together, they would go 18 thousandths closer together than they are, and the correct center-to-center distance is 14 thousandths closer, which gives you 4 thousandths of clearance. So that's starting to make some sense. So I think perhaps we've got our arms around the problem. So we'll have to now make some more gears and see if we can get it right.
So we're looking into why the teeth did not get cut as deep as they should have, and one of the things that I was worried about was that maybe there was too much slop in my setup here. Either the tailstock or the rotary table or something had some play in it, and that the gear was moving back, and that's why it wasn't getting cut as deep as I expected it was. So what I've got here, I've got a dial indicator held up against the right next to the gear there, against the shaft, and what I'm going to do here is press on this. Well, it's a little hard to see because I'm moving the camera at the same time I'm pressing it, but I can tell you there's not even half a thousandth of play there. I can't see the needle really move at all, so that ain't it. But anyway, we're going to look into some other things.
And looking into the reasons why I cut the teeth too shallow, I wanted to start a new gear, but I didn't want to cut a whole gear before I discovered how deep the teeth were. And so I looked into doing something to convert my tooth depth measuring equipment so that I could get in here and measure the tooth depth after I just cut 1 or 2 teeth. But with cutter in there and tailstock and everything else, it just seemed like it was too crowded. I didn't think I would be able to make something that would get in there, or at least not easily. And then it occurred to me that I didn't necessarily have to do that. The way this is rigged, I could take the whole assembly, gear and all, right out of there like this by just backing off the tailstock. And if I put the controller in the halt position, it would hold this table steady, and I wouldn't would hold the table steady. This motor wouldn't be able to turn, and I could take it out, make the measurement, and put it back. So I set out to convert my tooth measuring device so that it would it would work with the assembly the way it was. So that'll be the next step. This is our modified gear tester. We've raised up the shaft that mates with the gear, and also raised up the dial indicator. And this is a V-block, and this is what machinists use to clamp round things for machining. And I'm using one here, and we can take this is the of course the assembly from the gear cutter, and I've still got the old gear in there. And we can drop this right in the V-block and put a clamp on it like this, and tighten it up a little bit anyway. And I can still, this should be set where it hits these two screws so that it stays square. And I can still rotate this a bit, so when I turn this 90 degrees, I can make sure it's right at the bottom of the gear tooth. And now I can measure the depth of a tooth of a gear while it's still attached to the fixture that holds it in the I can turn this 90 degrees again. So it's still attached to the fixture that holds it in the gear cutter. So now I'm set to the objective here is I want to make a new gear, and but I don't want to cut all the teeth before I determine if the depth is right. So I want to be able to cut one tooth, bring it out here, check the depth, make sure it's right, or find out what it is, and then make any adjustments I need to make before I cut the rest of the teeth. And then once we've done that, we'll see how the gear works. So with that, we're going to go try our first gear. Okay, we're set up to cut another gear, and the other problem that I had thought about as to why I didn't cut the things deep enough is that I didn't do the touch off right. With the camera here and all the other things, it's a little hard sometimes to get in there and see exactly when the cutter touches off. So I'm going to try another technique that I've seen on some of the machining YouTube channels. I can use a piece of paper and put it between the cutter and the workpiece, and when the cutter first touches the workpiece, it'll pull the paper out from my fingers. So I'll just hold it very lightly at the tip, and I ought to be able to get it in here between the cutter and the workpiece, and when the cutter touches, it should pull it away. So we'll give that a try, see if that technique works, and then we'll try starting to cut another gear. Let's put it in gear. Okay. You saw that pull away there, and that paper is 4/1000ths of an inch thick. So if I clear the Y here on my digital readout, I want to come move the table in this direction. The 71 thousandths that I want for the correct the correct tooth depth plus the 4/1000ths for the thickness of the paper. So if we bring her back here to home position, and bring it back to home position, and let's see, okay, so we got to bring the table this way. 71 plus 4 is 75 thousandths. There we go, 75 thousandths. And now if we set this up to run, it ought to work. And here we go. Okay, we held down the halt button, so it stopped after cutting exactly one tooth, and now we're going to go measure the depth of that tooth and see how we did. Okay, taking a look at our tooth depth measurer now. Again, we've got the blank with only one tooth cut in it, and it's clamped in the V-block, and so now we can make the measurement. We've got it set to 0 here, and if I turn this 90 degrees, I got about 69 thousandths, so that's way up from where we were, and that probably was my technique for touching off that got us into trouble. So we're up to 69 thousandths. We're about 2 thousandths short, but that's understandable. That could be accuracy in this measurement, or whatever, number of different things could do that. So a couple thousandths I'm not so worried about. So yep, 69 thousandths. So I will set the the mill now to 2 thousandths closer, and we'll run the rest of the gear, and then we'll recut this first tooth. And then we'll be back when we got a complete gear. Okay, now we got a complete gear, and I just measured it, and it is in fact 71 thousandths on the nose. So that's what we wanted. And and so I'm going to take this out of here. You can see too that it looks more like a gear ought to look, I think. The other one looked just too let's see if we can get this in the picture here. You can see that the teeth look more like they're the right shape. You can see the taper on the ends, and it just looks more like a gear tooth here. There we go. So we're going to do the same thing now with the 31 tooth gear, and then we'll run them together in the and measure the center to center distance, and how they work when they're at the correct center to center distance. The 31 tooth gear is now complete, and I preset this tester so that the center to center distance is exactly 0.961 inches, which is is the correct distance according to all the formulas. And we can drop this on here now, and boy, they work just really nice and smooth. The the gears mesh well. They run smoothly together. If I hold this down, you can see there's just that tiniest bit of backlash, which is just what you want. You want a small backlash when they're running, and so I'm happy now. We got the gears right, and we know how to make them. Now, these are not the gears that are going to go into the harmonic analyzer. That's it's going to be a different module gears, the way the design is now. But the objective of this series was to get the gear making process right, and I think we're there. We will be starting a new series called Harmonic Analyzer, and that'll be delayed a little bit because we got another project that we're working on. With summer coming on, I want to finish an off-road vehicle that I built a number of years ago, and I got it all apart again. I got some of the parts painted and plated and that kind of thing, and I'm fixing a couple problems with it, and we'll be putting it back together. So I'll make some videos about that, and then probably when the later on in the year, why we'll get back to the harmonic analyzer. That's all for this series, and I'll be back. We'll see you real soon. And thanks so much for watching. I'm getting more and more subscribers and more views as time goes on, and I really and got a number of people that have sent me comments and expressed interest in what I'm doing, and we've been able to exchange information with several different viewers who are interested in duplicating what's happening here. So with that, we'll say goodbye for now.